This is Module 2, Lecture 1 on Research Design and Data Management. We start first with a discussion of the principles of experimental design for life sciences. That is, planning biomedical studies. So we start first with some definitions. First, aim. We know we have to write a specific aims page. So what is an aim? A clearly directed intent or purpose. So something specific that you are planning to do. Objective, something towards which effort, the aims of course, is directed, an aim or end of action. So if we look at strict dictionary definitions, aim is used to define objective and objective is used to define aim, but they indeed are distinctive. The aim is most specific, the objective is a bit more global. The goal is even more global, the end toward which effort is directed, an aim. So we see from the dictionaries that they are almost all defined by each other, but in the terms of science they are from specific to general. The aim is the most specific thing. What exactly are you intending to do? And what is your objective? What will you accomplish by achieving your aims? And the goal is a more broad type of a planned endpoint that the aims and objectives will contribute to. May not solve the goal or achieve the entire goal, but will contribute to the goal. The collective aims of a research project should achieve the collective objectives, or objective if there's only one. Thus, in the specific aims of a research proposal, we are asked, and this is from the NIH guidelines for the R01 application, the PHS Forms 398 that are used for more than the R01 Investigator-Initiated Award. In general, these are the recognized definitions across the board in research and writing research proposals and completing experimental projects. So list the broad long-term objectives and what the specific research proposed in the application is intended to accomplish. So here we see the terms objectives. These blanket the intended accomplishments, the specific aims. State the hypotheses to be tested. So also in this first part of talking about specific aims, the premises upon which the hypothesis stand must also be stated. In the background and significance portion of a grant proposal, such as the NIH grant proposal, as I had stated, you are asked briefly sketch the background leading to the present application, critically evaluate existing knowledge, and specifically identify the gaps which the project is intended to fill. So here we see that theoretical framework as we had it designed in a previous set of lectures, with facts and strongly supported hypotheses, weakly supported hypotheses, and gaps in the theoretical framework. And hypothesis-driven research expected by NIH is that you generate the hypothesis from the gaps by asking questions and design experiments to test those hypotheses and contribute a supported hypothesis back to the theoretical framework in attempts to fill the gaps. So in writing a grant proposal, it is extremely important to point out and even to use the term gap. The gaps in our knowledge, or this is a major gap in our knowledge, which if we do this, we can collect this type of information, we can have this type of idea to fill that gap. That's the type of wording that should be used so that the reader understands exactly why you're pointing out a gap and what you expect needs to be done and what type of information needs to be gathered in order to have a plausible and supported idea to fit back into the theoretical framework to fill the gap. You state concisely the importance and health relevance of the research described in this application by relating the specific aims to the broad long-term objectives. Basically, this is the goal. So your aims, we'd have one or two aims that are under one objective, and if you achieve that objective, we are one step closer to making a difference relevant to a particular health concern for the NIH in the United States or world society. As well, you're asked to provide preliminary studies or a progress report. So as we continue our lectures on this topic of experimental design, the responsible conduct of research, we will talk about how important preliminary studies are. Of course, if it's funded and you're submitting for renewal, it would be obligation to include the progress report and possibly preliminary studies for the next phase of the study. For new applications, you would put in account of the Principal Investigator Program Director's preliminary studies pertinent, misspelled, to the application and or any other information that will help to establish the experience and competence of the investigator to pursue the proposed project. Next then will be the research design and methods, in which you describe the research design and the procedures to be used to accomplish the specific aims of the project. You'll include how data will be collected, analyzed, and interpreted, describe any new methodologies, discuss the potential difficulties and limitations of proposed procedures and alternative approaches to achieve the aims. So in your assignment to write a research proposal on one specific aim, this is the outline that you will be asked to follow. I will have other lectures where I give examples on these, and we will also study experimental design theoretically and technically, if you will, to appreciate why these requests or the guidelines are written as they are. So therefore, in summary, the research design and methods are set up as the specific aim, a rationale, the design, data acquisition, data analysis, expected results, and the alternative interpretation. What if you don't get the expected results and you have to link it to other specific aims? If specific aim 2 depends on specific aim 1 being successful, your proposal is very weak. What if you don't get the results you expect in aim 1? Aim 2 is completely dead. But you still have to have some link, otherwise the aims don't contribute to objective and to goal. So let's take just a moment to think about this. We rephrase or restate our specific aim. What is it exactly that you want to do, to accomplish? Well, what's your reasoning? What is your rationale for wanting to approach it in that one particular way? And then what is it exactly that you're going to do? You know, not down to the details of, well, I'm going to use 20 millimolar calcium or purchase my cell line from this source, but a person should be able to read your design and picture what you're doing without being bogged down with detailed methods and procedures. So this is a description of what will be done, and quite exact, as we will see. Exactly how are you going to get the data, instrumentation, early manipulation is a term, but I like to use processing of the data. How will it be analyzed? Further processing after collecting the raw data in a tabular form. Are you going to calculate differences or percent differences? Are you going to normalize in any way? The statistical analysis is key, and any steps that you're going to take to try to proceed from ruling out chance and then establishing correlation and establishing causality. So exactly how does your design accomplish that progression from 0% to 100% association? What are your expected results? Therefore, you have a link to preliminary studies. If you don't have any preliminary data, it's awfully difficult to substantiate expected results. You can't have the work completed yet. We just, in the previous lecture, talked about plagiarism. You can't do that. Alternative interpretations. So we have an hypothesis that we're testing, and there's always an alternative hypothesis. What if you don't get the evidence to support your first hypothesis? You've got to have another idea in mind to interpret and explain the data. And typically, you will have links to other specific aims. So what this demonstrates to us is that there is a one-to-one-to-one correspondence between the study objectives, the experimental design, and the statistical analysis. And this is going to be the focus. There must be a theme, a repeating theme through an entire research proposal, specific aims page, backgrounds and significance, experimental design, and methods. It must flow in a very consistent pattern. If they're out of order with one reference to the other, then it's a poorly written proposal, and the reviewer's enthusiasm dwindles very quickly, regardless of how important the research might be. So understanding this one-to-one-to-one correspondence is extremely important. And what we will state, essentially, and I don't think anyone will really argue, is that you must start with the statistical analysis after you've come up with the basic framework and actually work backwards. If you only work forward, collect your data, and then ask the question, what statistical analysis is appropriate, you are dead in the water, and it is absolutely the backward approach. You start going forward and put together key ideas, and then seek out the statistical approach and work backwards to refine experimental design and study objectives. So let's think about the development of objectives and appropriate measures, or what to expect. So goals should be translated into objectives. So goals are more global and objectives more specific. There are ideals that you will aim for, whereas objectives will have a measurable quality to them. So you might have 2 or 3 approaches to measure some quality about the objectives. So we are beginning to see the building block nature of goals deriving into objectives and deriving into aims. So here's an example. If you're evaluating an institution from a department or division point of view, the division will produce superior graduates. The objective: graduating seniors will score on the average at the 90th percentile of students statewide on a licensing exam. An aim would be to have course content and exercises appropriate for developing at least the skills required to reach the objective. And you can have various aims, as you see. Goals can also be interpreted in a more qualitative way as well as a quantitative one. For example, the division will produce superior graduates. The objective: students will be rated by their employers regarding students' dedication, efficiency, productivity, ethical standards, initiative, creativity, etc. on a survey form, eliciting comments and ratings. So you can't really quantify these with an infinite number. They're usually ranked or scored. And we'll talk about these different type of data as we proceed through other lectures as well. Questions can be used to identify an assumed goal or objective. Ask all possible questions about how UTSA and its students fare across all aspects pertinent to your goal. What are the questions you want to ask? What goal or objective do they evaluate? So even though this is obviously some material from a committee that I served on, although I unfortunately didn't make significant contributions on this, I don't want to claim anything that I didn't really contribute to. I got started on this, and then others took over. But I liked the materials that were provided because it lets us see another example outside of research of how we use questions to generate hypotheses, to get aims, to do something specific. The aims collect into objectives. The objectives contribute to the goal. The number of objectives in the study should be limited. I believe that 3 objectives should be the maximum number under investigation in almost every study, and this is from M.R. Selwyn's Principles of Experimental Design for the Life Sciences, one of the texts for our course. So 3 objectives, 1 goal, 3 objectives, and maybe only 3 aims, or 3 to 6 aims. If you have 9 aims, 3 per objective, that's quite extensive for a single study, even if it is a 5-year study. Identifying subproblems. So this is from P.D. Leedy, Practical Research Planning and Design, the Chapter 3. So what are subproblems from our perspective? Well, I see these as trying to set up our aims, objectives and aims. So sifting through from the overall picture to breaking it down into subproblems, and then even further into subproblems under the, in other words, objectives to specific aims. So they're not procedural questions. For example, decisions made outside principal research environment. What is the best way to choose a sample? What instruments or methods should be used to gather data? What measurement instruments are available? How large should a representative sample of population be? How do I find subproblems within the main problem? So these are procedural questions that are am I interpreting that wrong? Excuse me. These are not procedural questions, sorry about that, that contribute to the identifying of the problem. So the characteristics of the subproblems, each should be a completely researchable unit within a larger goal. So subproblem being an objective under a goal. Each should be clearly tied to interpretation of data. Parts must be equal to the whole, so aims must contribute to objectives and be very clearly delineated and composed as such. Proliferation of subproblems is circumspect, so if you end up with far too many aims, it really doesn't get you to a particular point. It's just hard to believe that so much would need to be done to reach a particular objective. So in other words, not a well-developed research proposal or project. So be careful to consider all circumstances and possible consequences under Webster's dictionary for circumspect. So it is important to be careful to consider all the circumstances and the possible consequences, consequentialism, but you can end up with more subproblems than what is reasonable, so therefore you have to consider those with the best consequences and only include those subproblems that are most pertinent, specific aims to objectives. So beware of unrealistic goals in that sense. So you begin with the problem itself, the goal. The overall theoretical framework is a good guide to that goal. Write about the problem. So write subproblems with clear, direct links. So do an outline, goal, objectives, aims. Align the subproblems to add up to the whole. There is a logical progression. And ours, of course, as I've said repeatedly, is I have this overall theoretical framework that encompasses or has direct relevance or states my goal, and I've identified the gaps problem or problems, and this leads me to certain objectives, a set of objectives, and each objective has a set of aims under it. So therefore, we're working on delineation of the problems, delimiting the research, so it cannot be overextensive, it cannot be just a free run of ideas, it cannot be a wild goose chase or a fishing expedition. Have to have clear definition of terms, state the assumptions, state the hypotheses and or research questions. Sometimes there's a research question that really is not best approached by hypothetical hypothesis testing. And what is the importance of the study? So basically this is the same as the instructions for writing the background and significance. So what exactly will and will not be done? So you delimit it down to the level of specific aims under your objectives, define the terms, clarify all possible sources of confusion and any possibility of being misunderstood. So you might think that something is universally recognized and known, but it may not be. State assumptions, so you, in your background and significance, you build on the rationale for your approach. Justify the model and approach in the rationale portion under experimental design and methods. You get into it more specifically. So for example, in the background and significance, you talk about this research group and that research group and that research group and their publications, and they utilized this method, this approach, and this is what they demonstrated, but this is the gap, and their work doesn't contribute to that. Then you get to your rationale, and you might list the same researchers, and you say, well, they used, you know, this specific method, this specific instrument, this specific drug, and now there's a better approach, a more sensitive instrument, and so on and so forth. You get into the specifics of how they performed their work in the rationale, and how they contribute useful information for your specific approach, and how you have modified your approach to be unique. But in the background of significance, you're just treating their contributions to our knowledge more globally, but still you can reflect on methods. So in other words, when you identify a gap, you say, well, what would we need to know to fill this gap? What would we need to do to get the information to fill that gap? Exactly how can I do the research to get the information to allow us to fill that gap? So you state the hypotheses, or hypotheses are research questions, so that it is a guess, clearly phrased statement, and more easily proved wrong. So the statement of an hypothesis should be as brief and to the point as possible, and more easily proved wrong. So our actual approach in science is to disprove hypotheses. If you do everything you can, do every experiment in the world in order to disprove your hypothesis, and you cannot ever disprove it, it is proven. It's supported, right? So that's the true hypothesis testing approach in science. We want a hypothesis that is so easily proved wrong that it becomes more of a challenge when you cannot disprove it. Importance of the study, so there has to be practical value to it, utilitarianism there. Cost versus benefit, utilitarianism again. So in evaluating your research plan, you have to go back and take a look at it after you've thought it out originally, and you do it repeatedly, and then of course there will be reviewer evaluation in the end. Can you clarify your plan with your peers to satisfy their questions? So talk to other people about it, have them read over portions. What comments have they made? Everybody will always have little something to contribute. What concerns have they shared? And be sure that the data supports your conclusions. Work it back and forth, making sure that what conclusions, even if they're preliminary ones for your expected results and how you will interpret it, are directly related to the data as it is extracted from the experimental design. So 20 steps to a proposal. Browse, converse, think, ideas sprout, what if, what does, narrow it down, what do I want to know, formulate a clear, specific question, identify the gaps in our knowledge, determine why the answer might be important, what is the significance, survey the literature, and The source of this table is given, and I have it enlarged on the next slide, and we'll read through it. Does the article have a stated research question or problem? That is, could you determine the focus of the author's work? Is this an article that describes the collection of data, or does it describe other studies in which data were collected? Was the article organized in a manner that was logical and easy to follow? What could have been done to improve its organization? Did the article contain a section that outlined and reviewed studies that had previously been done on this topic? In what ways was this previous literature relevant? If the author explained procedures that were followed in the study, were they clear enough that you could repeat the work and get similar results? What additional information would have been helpful or required? If the data were collected, could you describe how they were collected and how they were analyzed? Do you agree with what was done? What additional things would you have completed? Do you agree with the interpretation of the results? Why or why not? Finally, reflect over the entire article. What was most important to you? What did you find most interesting? What do you think are the strengths and weaknesses of this article? Will you remember this article in the future? Why or why not? So if we evaluate every single research article we read with this outline by our side, this series of questions on our side, and we outline our responses, then we have a clear and careful approach to generating the first phase or the first draft of our research proposal. All the questions in here you see are directly related to every part of the research proposal we talked about: background, specific aims, the background significance, the rationale for experiments, and even the experimental design. And certainly giving credit where credit is due and making sure that is novel work that we're working on. So then step 7, after the research, write summaries of the articles. Make an intensive review of the literature. Consider alternative forms of inquiry. Rough out the design of the experiment. This is a good time to start sharing ideas and discussing it with other individuals. Remember, we share ideas openly and freely, but ideas are our only possession in science. Consider alternative methods of measurement. Consider alternative methods of analysis. Review and redesign. Specify all procedures in detail. Prepare the first full draft of the proposal. Abstract and outline first, and then you do the full draft. How rare is it that individuals take this approach anymore, do an abstract and then generate a full outline of their proposal before they get started. Share and discuss with colleagues and the advisor. Conduct a pilot study, analyze the data, and review all the procedures. So before stepping up to the bench to begin a pilot study, all of this should be completed or nearly completed. Prepare revised draft proposal, present to the committee, explain and support, gather data, process and interpret as planned in the proposal, and then write the articles to report the results. So obviously this is an extensive overview of grant writing proposal, and I encourage you to begin thinking about your